Accurate data collection and observations of your prototyping process are both huge parts of the STEM world. So when we take a look at the scientific method and the engineering and design process, in the scientific method, you're more so going to be conducting experiments. And from those experiments, you're going to make sure that you are collecting plenty of data. In the engineering design process, rather than an experiment, you're going to be prototyping. And within that prototyping, you guessed it, you're going to be collecting plenty of data. Now in an experiment is going to be a scientific procedure undertaken to make a discovery, test a hypothesis, or demonstrate a known fact. As well as a prototype is going to be a typical or preliminary model of something, especially a machine from which other forms are developed or copied. Now when we take a look at types of data that you could collect in either of these processes, you're going to have two main types. One of those types is going to be quantitative data. And quantitative data is going to be data that's measured using some sort of an instrument, such as a graduated cylinder, beaker, or thermometer. This could be something like size measurements, volume measurements, or temperature of a substance. Our second type of data is going to be qualitative data. Qualitative data is going to be a type of data that's collected using observations using your senses. Some examples might be color, taste, sound, and smell of an object. So let's take a look at our prototyping example that we've been following along, which is working on bikes. No matter if you're conducting an experiment using the scientific method or you're conducting a prototyping investigation using the engineering design process, it's super important that you take meticulous notes so you know what you plan to do, as well as when you look back at your notes, you know what it is that you did in order to get to the result. You might remember my squeaky bike that I have the plan of trying to tune up, so that way it makes less noise and works more efficient. So in order to fix up this rickety old bike of mine, I got to work conducting the engineering and design process in order to tune up my bike. While doing this, I made sure to take meticulous notes so I knew what exactly it was that I did and when I did it. One thing that my research suggested that I try in order to tune up my bike is to simply clean up my bike. So that was the first thing that I tried. And that helped a little bit, but I still wasn't satisfied. So I got back to work. What I found was that oiling my chain on my bike made a significant change in how quiet my bike was, as well as how much smoother of a ride it was. However, my brakes weren't working great. So I did some more work and figured out how to adjust my brakes. And now I'm smooth sailing on the bike. Let's take a look at our experimental example. Can crushing 101. How does heat affect the movement of water particles? Once again, I got to work making some pre-observations and recording some notes and writing down my procedure. So we're going to take a look at my notebook. You'll notice that in my notebook, what I've got here is I've got several different things. So one thing that I've got is I've got the title of my demo that I'm planning to do. I've got my problem statement, my hypothesis. I've got my variables listed out. I did my research. I made sure to include the source that I'm using for this, as well as what I've got here is I've got my procedure listed out, so I know exactly what it is that I'm doing when I'm actually conducting my experiment. Now, what I've also got is I started to collect some preliminary data. Now, your data collection can quite often just be observations. Okay, so you'll notice that some of my observations that I've got here is I've got listed out my can's dimensions. There's my can. And I've got them listed up And I've got a diagram drawn of what the can looks like beforehand. I've also got the temperatures of the cold and the hot water that's going to be used in this experiment. Alright, so what I've done here is I've got all my supplies gathered up. I've got my ice bath prepared. I had to use green food coloring instead of blue because my blue actually ended up bleeding all through the box. I've got a towel so I can clean up after. I've got my aluminum can here on the stove that I'm going to turn on high in order to start heating up the tiny bit of water that I've got inside the can. And I've got my notebook here so that way I can read through the procedure as I go. Now what I'm doing here is I'm heating up this aluminum can. You'll notice that there's going to be some flame. I'm going to turn that down a bit, and I'm seeing that water vapor come up, and I want that water vapor to come up for at least 30 seconds, so that way I know that water that's inside that can is nice and hot. Now I'm not using tongs in this experiment, I'm using insulated gloves, so that way I don't actually need the tongs and I'm not going to hurt my hand. So once I see that water vapor rising up above the can for a little bit, then I'm going to quickly dump it into my ice water bath, top down, and we're gonna see what happens. Been seeing that water vapor go pretty good for a while, so I'm gonna go ahead, I'm gonna turn off my burner, take my can, let's take a look at what happened. It's looking a little bit different from what it was before. The poor can. So now that I've actually completed my demonstration and I've got my crushed can over here, now what I'm going to do is I'm going to go ahead into my data collection section and I'm going to want to make sure that I make my post observations. Now when I take a look at my post observations, you'll notice that I recorded the temperature of the combined water, as well as I made a new diagram indicating the dimensions of my crushed can. So once you make your actual data collection, then it's going to be time to start making your conclusions.